Let's go through Liquid 428. Serialize and deserialize the N-ary tree. So for this question, it give us a N-ary tree, and let's serialize it and implement the serialize and deserialize function. For serialize, it converts this tree to a string, and deserialize is that we based on this string we reconstruct the tree out. So what we're thinking about is that so this inner tree, the tree has a node value in the list of nodes, which is children. So it has two constructors. One is put the value of it, but if we put the value as the constructor variable, this kind of children, it is possible it is none, and also, there is another one that is passing the value and also list of nodes children. So it's better we use the second constructor so that well sometimes we may forget to initialize the list of children. It will not be a problem. What we're thinking about is that for this tree, right? We do the traversal from the root and to its parents, uh, from the post post order traversal, right? So from the root and all of its children. So if this is a tree, right? This is a node. What it happen? For example, this is the value 23, right? So it will have 23 for this. And then there is we use up brackets to represent those kind of subtrees has a node start with 23. For example, this is 4, right? So then we have 4. If this one doesn't have a subtree, just use a comma. And for example, this is 10. And it may have subtrees, for example, 1, 2, 3, right? So what we do is that we're going to have 10 and have brackets here, right? Because it has subtrees 1, 2, 3, right? For example, there is 9 here, so we have a common 9, right? So we'll say we are serialize inner tree, which have the tree's root value as a first element, which is before the brackets, and also its children collection, which will be inside of the brackets. So when we deserialize, what we do is that we compose the root value here, and we strip the brackets. So that means we are able to get all of the child collection, right? So we need to have separate functions to separate this out, right? So this separate function, we cannot use a string split because, for example, this one, the comma inside of the brackets, we should ignore it. So what we deserialize, it will deserialize 4 and 10, 1, 2, 3, right? And then 9. Well, deserialize to, when we deserialize, it was put this as 3 substrings. And for each substrings, we recursively to deserialize. For the exit condition is that for this kind of substring, right, it doesn't have brackets in it. Then we just have a create a node which is just because this will be a leaf, right? Just create a node for this kind of single nodes. So this will be the process. So we know this process. Let's write code for this, right? So let's say if root equals none, we can return an empty string. And then what we do is that we're going to have a string builder equals to new string builder. And what we do is that, of course, we need a string builder to append this kind of root dot value, right? And Well, say if this one is already leaf, this root, that means it doesn't have child. We can have have a corner case here, right? So if uh, root dot children equals null, or root dot children dot size equals 0, right? In this case, we can just return string builder to string. Um, so we'll say this is for the single for the leaf, right? For the leaf which don't have any children um with it. Then for this root, if it has a children collection, right, and also have the children uh for it, what we do is that we're going to have a string builder append this kind of brackets, left brackets, right? And also we need to have string builder to append the right brackets and the return string builder to string. So then what we do is that we recursively call its children. So what we do is that for node child and root dot children, then we need to string builder append. We serialize child, and we need comma to separate it, right? And if doing this, there is an actual comma uh, for this kind of this part, right? So let's remove string set length string builder dot length -1, right? So this will be our serialization code. And for deserialization, we can also write similar. So I'll say if this kind of data equals null or data dot length equals 0, right? Then we just return unknown, return null. So we look at for this string whether there is brackets, right? We can do this in the first left bracket, the first left bracket index. Set this one in as data index of this, right? And the last, we have a last right bracket index equals data index of the right one, right? So we'll write if there is no left brackets and the right brackets, right? If f index, let's say f index and the last index, okay, f index equals -1, and the last index equals -1 means this is a leaf, it's a single value, right? So we'll have int v equals integer dot parse int data, and what we need is just a return new node v. Let me see. Let's always put a new array list here, so that if there is multiple calling deserialize and serialize multiple times, right? So and we don't need to worry about any non exceptions here, right? So actually for this one, it's better, right? We create a list of children in this constructor. Um, so we create an empty one here. And so what we do is that then what we need is um, so first we are seeing before this first brackets, right? So the substring from 0 to first index, we can pass that as 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 a value, root value, right? So we'll have int v equals integer parse int data of substring from 0 to first index, right? And let's have a node result equals new node v and new array list. We need a split function to split the format, for example, A, B, C, D, comma E to be A, to be this part, and this part, right? We need a separate string split helper. So we'll say um, for string as a, let's have this one, list of string called str list equals string split data substring. So it will be from the first index plus one, right, to the last index. Because this is the first, this one will be included. This is excluded, right? So we'll write this one. So for every string in str list, we recursively call result dot children dot add deserialize s, right? And then in the end, just a return result. And a private list of string We need a string splitter of string extra. So to write this, we have list of string result equals new array list. We need an int last index equals -1. And we need to count the brackets, right? So that since if I see this left brackets have a count increase by 1, and the right brackets, it will have the counts -1, right? So for only for those kind of commas which we have this counts equals 0, then we will say this is a valid comma. So we're going to have an count equals to 0. Let's have n equals s dot length. So what do we do is that for int I equals I smaller than n, I plus plus, then we're going to have char state equals s dot char at I. Then we'll have if state equals left, we'll have counter should increase, right? And else if C equals right brackets, we'll have count minus minus, right? So what we do is that if this count equals 0 and C equals comma, then we can have result should add from S dot substring last index +1 to I, right? And we'll also have last index set as I. And after this one, this for loop, right? So we'll see only when there is a comma we'll add a result, but that we missed the last one because there is no comma after that, right? So we should add the last one as well. Also, if for example this kind of string it doesn't have any commas, right? We should also add this kind of string. So we can use one one sentence of the code to cover these cases, the two cases. So we'll have result add as substring last index plus one to find, right? So in the end, that's a return result. Serialize set a length percent. There is some problem range at line 52. Split. This is the last index. Sorry, index. Last index of because what we want is that not the first one, right? We need to get the last one, and we recursively to find the only the last will be that will be its children, right? So it will be last index of. So we'll have ON time complexity because for every node, it's going to have the post traverse once, right? And this is a recursive call. So the space complexity will be OH, and deserialize is the same thing, right? Time complexity is ON, and space complexity is OH. Let's write a Python code for this. Um, so we'll write. If not root, just return an empty string. And we'll have result equals str change root dot value. Okay. Then if not root dot children, then what we do is that return results, right? So the children is empty. Then what we do is that we are going to have result should plus equal to this. Um, then should have, for example, we have this one. Um, have this one dot join self dot serialize child, right? Um, for child in root of children, and we should add right brackets and then return result, right? So this will be the serialize. And for deserialize, so we have the same, the same thing. If not data, return none. And then what we do is that first index equals data dot find this char, and the last index will have a data right find this char. So I write if first index equals -1, And the last index equals -1. Then we just return a node int data and empty list. And we're going to have value equals int uh, data. Change this. We have a range from 0 to first index, right? And this will be the value. And what do we need? We need a child string, right? Child string equals data from first index +1 to uh, last index, right? Then we'll have um, children equals self dot deserialize as for s in self dot let's have a string split, right? String split children string, child string. It's called children string, right? Children string looks better. Children string. And what we return note this value in the children, right? So also we need to define the split string split function, right? In str, which are going to return a list of str. What we need is result equals a list. Um, we we're going to have a last index equals -1, right? Last index and count equals 0. Um, so we need an last index equals -1, count equals to 0. So what we do is for I, say enumerate s, if the c equals left counter bracket, we have counter should plus equal to 1, right? And else L if c equals right, we'll have counter should minus equal to 1. So we'll say, well, right, if c equals comma and count equals 0, right? In this case, we're going to have results should append s dot last index +1 to right. And we also have last index. We should set this one as I. And in the end, don't forget to append the last index +1. We should add the last one, right? And yes, last index +1 to the end, right? And then return result. 10. And this is here. Okay. O n time complexity and OH space complexity because of the recursion code.